This is Geometry, section 7.5, Proportions and Similar Triangles. So we just have a couple theorems in this section that are going to help us solve problems involving similar triangles, especially overlapping similar triangles. So the first is called the side splitter theorem. Side splitter theorem says that if a segment is parallel to a side of a triangle, such as this segment right here, it's parallel, these triangles mean parallel, so this segment is parallel to this bottom side of the triangle, then the two triangles are similar. So this small triangle that's created when I draw in this side is similar to the entire original triangle. So the small triangle compared to the big triangle would mean we could compare A to, we need to be careful here. So A is this side of this triangle. The corresponding side of the big triangle would be this entire side. So that's really going to be A plus W, whatever those two numbers are. Same thing over here. This entire side is going to be H plus K. So A is going to compare to A plus W, and H is going to compare to H plus K. However, when we get here, E is the entire bottom side of the small triangle, and M is the entire bottom side of the big triangle. We don't have to add anything together. So also for the sides that we split by that segment that's parallel to the bottom, we can also just compare the pieces, so hence the name side splitter theorem. So the sides that are split, we can compare those pieces to each other, A and W and H and K. We could also compare it sideways, so we could compare A to H and W to K. The reason is when we cross multiply this, if I cross multiplied W and H and A and K, and then W and H, A and K, I get the same thing. It's really the same proportion, just in a different order. So using that, find the value of the variables. This is our side splitter, so to speak. So we could compare 16 and X to 20 and 15. We cross multiply that. When we cross multiply, we get 20X equals 240. And when we divide by 20, we get that X is 12. Now, to compare Y is the entire bottom side of the big triangle, and it compares to 8, which is the bottom side of the small triangle. So we have to compare 8 and Y, but then we have to be careful because 8 would compare to either 20 or 16 on the small triangle. We could use either one. So 20, if we pick that one, that's going to compare to, again, this entire side of the big triangle. So we have to add up these two numbers, 20 and 15, to get that this entire side is 35. So when we cross multiply this, we get that 20y is equal to 280, and then when we divide that, we get y equals 14 when we divide by 20. Y is 14. All right, for this next one, similar thing. First, we start with knowing these two entire sides. So we start with 21 and 6. Those are the two that we know, because then we have a variable over here and we have a variable over here. So if I compare, let's go big to small this time, 21 to 6, this entire side of the big triangle compares to just this piece of the smaller triangle. So 35 would compare to D. If I cross multiply this, let's see, we would get 21D equals 210, and then when I divide, we get the D equals 10. So if D is 10, now we can figure out what this other piece is, this other piece of this entire side. If the whole thing is 35, 35 minus the 10 that I now have is 25. So now we can use the side splitter theorem to solve for A. We can compare A and 20 to 10 and 25. So when we cross multiply that, we get 200 equals 25A. Divide by 25. A would be 8. Oops, 8. All right, another one, the triangle angle bisector theorem. So if an angle of a triangle is bisected, which we know means cut exactly in half. So for example, this angle right here is cut into two 43-degree pieces. So that means that angle is bisected. Then we can use the proportion. The two sides of the angle that's being bisected, so A and B, would compare to the two pieces of the side that the angle bisector cuts into two pieces, H and K. So we always go in the direction of the angle bisector from this side to this side to that side. A over H is the same as B over K. So using that here, this is the side or the angle that's bisected. So we're going to compare this and this, this and this. V over 4 would be the same thing as 18 over 6. Remember to go in the same direction for both ones. So draw in the arrows, sometimes that helps. So draw in the bisector and then an arrow from one side to another. Cross multiply this and we would get 72 here. When we divide that, we get that V is 12. Over here, same thing. Angle bisector right here. Cutting this into two 34-degree pieces. From here to here, here to here. 16 to 10 compares 8 to W. So cross multiply this. 16W equals 8 times 10 is 80. When I divide by 16, we get that W equals 5. All right, here's my angle bisector. This piece is called X. I've got 15 and 18, so I need to compare 15 to X. And then we've got a problem here because 18, this doesn't have anything with it. So if the entire thing is 22, we don't know what X is. We can't just subtract a number from 22 to figure out what this piece is. But we do know that this is X. So we can just write 22 minus whatever X is for this piece. So when we set this up, still set it up the same way. 15 goes with X, 18 goes with 22 minus X now. Okay, and then when we cross multiply this, we just have to be careful that we distribute. So here and here, we're going to get 18X. And then we're going to have to distribute that 15 to the 22 minus X. So when we do that, we get 18X equals 330 minus 15X, because distribute it to both pieces. And then we want to add the 15X over here to get all the X's together. So that's going to give me 33X equals 330. And then when I divide by 33, we get X equals 10. Over here, similar situation. This is my angle bisector, cutting this into two 50-degree pieces. 20 compares to, we don't know, and 10 compares to Y. So same thing. The whole thing is 24, so we'll call this piece 24 minus whatever Y is. 24 minus Y. So 10 compares to Y, 20 compares to 24 minus Y. Cross multiply again. 20Y equals 10 times this whole thing. 10 times 24 is 240 minus 10Y. Add the 10Y to combine all the Y's together on one side. So 30Y equals 240. When I divide by 30, we get that Y equals, oops, not 80, 8. Just 8. All right, and the last one for this lesson. If 3 or more parallel lines, such as these ones in this diagram right here, 3 or more parallel lines are cut by transversals. Again, transversals, we learned that word a long time ago. It just means a line that intersects parallel lines, or any two lines. So if these 3 parallel lines are cut by any other line, then we can use this proportion. Same thing as the side splitter theorem. These two pieces compare to these two pieces. A over B is the same as E over F. Similar to the side splitter theorem, and if we kind of extend this to make a triangle, it looks like a triangle with a side splitter in it. So we're just going to set up proportions. We could also set it up. We did A over B equals E over F. You can also go across and say A over E equals B over F, as long as you keep the order consistent and you don't go diagonal. You can't go from A to F and B to E. You have to go straight across or straight up and down. So the proportions are kind of written for us. 4 over 12, 6 over W. 4 over 12 equals 6 over W. Cross multiply. And we get 72 equals 4W. When we divide by 4, see if there's a line down here for me for my variable. Way down here. We get 18 for W. All right, same thing here, except again, we have this problem where we don't know what this piece is. We do know this whole thing. So since this is X, we call this 28 minus X. So again, the proportion is set up for us. This over this equals this over this. 15 over 28 minus X equals 20 over X. Cross multiply. 15X equals, we have to remember to distribute the 20. Oops, minus X. So we have 15X equals 20 times 28. It's 560. And then equals, minus 20X. When we add 20X, we get 35X. 560 is left on the other side. And finally, when we divide by 35, we get that X equals 16. All right, the last one over here. This one has multiple parts to it. So we've got variables here and here. All three of these lines are parallel, and these three lines going this way are transversals. I can compare any two sets of these numbers. So here and here, I can compare those to this and this. I can compare these to these. I can compare these to these. I can compare any combination of two numbers that I want from these different transversals. So since we know both of these, let's start here and work our way up. Let's solve for y. So again, the proportions are already written for us. 36 over 34, y over 51. Cross multiply. When we do that, we get 1836 equals 34y. And when we divide by 34, y is going to leave us with 54. So now if this piece is 54, we can set up another proportion to solve for z. Z over 36 equals 60 over 54. Same thing, when we cross multiply and figure all that out, we're going to end up with, or you should end up with, z equals 40. You can try that one on your own.